Good morning, good afternoon. My name is Robert Schmid, also known as Mr. IoT. I am the Chief IoT Technologist for Deloitte with a deep passion for all things digital. This week on Coffee with Mr. IoT, I'm talking with Skip Ashton, VP at Silicon Labs, and we're going to talk about standards. Skip, thank you so much for joining us. How are you?
Excellent. Happy to be on.
It's great to have you. Skip, you and I met actually at a Zigbee conference, and I have to tell you, it was great to have you. You know, when you stand up there and you have to facilitate a room, it's always great to have someone who's as interactive as you are. You are really passionate about standards. What is it? You spend a lot of time on standard boards. Just
Yeah.
tell me about that.
Yeah. Maybe I'm too passionate in everything I do. That's what my kids will tell you. But if you're going to do something, you might as well do it, right? There's no halfway doing it. So yeah, I've been working on these wireless mesh since 2003 when I joined Ember, which then got bought by Silicon Labs. So we've been at this. It only took us 10 years to be an overnight success, and it only took 10 years for Zigbee to get recognized out there. But you're right, we do a lot of different standards really across the low power wireless. That's really a big focus for Silicon Labs and a big focus for myself.
So tell me, Zigbee is one of the standards, but there's multiple standard boards. You've been at this for 10 years. Just give us a little bit of history. How does this go? I don't know. I know you've done it with wireless, and wireless is a bit more advanced than what we do in the Internet of Things. So give us a look back at wireless and how is that going to relate to Internet of Things?
Yeah, so to be fair, we actually started with a proprietary mesh network back in the day. We shipped something called EmberNet for our early deployments, and that worked great. But we realized that if we were actually going to really scale and ship a lot of anything, it needed to be standards-based, right? Bigger companies really want to do standards, and you get in the situation where companies that make light bulbs actually don't make light switches. But consumers really think their light bulb should work with their light switch. And so if I'm going to make a wireless light bulb, it probably needs to speak the same language as every light switch out there. So the light bulb manufacturers either need to go to talk to every light switch manufacturer, or they need to create a standard and try and get people to do it. So, that they really then help to drive the industry. And from our standpoint, we look at this, it's not one single thing. There is no standard that wins, even though people like to think there's going to be one that wins. And so we're very involved in Zigbee. We're very involved in Thread. We're very involved in Bluetooth, particularly Bluetooth Low Energy and Bluetooth Mesh. And we actually have a very large business in proprietary wireless because there's still a lot of that goes on. So those for us are the four pillars of low power wireless that really get used in a lot of systems, right? And so you don't actually think about how much proprietary wireless you use in garage door openers, the key fob for your car, those sorts of things, which are actually point-to-point proprietary quite often. There's a lot of systems like that. Many of the home security systems continue to operate on proprietary sub-gigahertz. And so my customers really operate in 1 to 4 of those areas, right? So they don't actually today traditionally only do one thing. If I do a Zigbee product, I might want to use Bluetooth for commissioning in that same product because it makes it easy for consumers since we all are addicted to smartphones, right? If I have a legacy proprietary business and I still want to talk to those devices, I might decide my future business is going to be better if I switch to Zigbee. So I keep working with those legacy devices, but I then shift new products onto Zigbee, and I need chips that do both. And so you're seeing more of this kind of multi-protocol wireless out there from us and from others because that's the way these standards unite and the products unite. And your cell phone is a very good example of that I use for people who say only one thing can win, because your cell phone has a lot of radios and a lot of technology in it, and you as a consumer don't actually care.
So if I heard you right, many people start proprietary first because there are no standards, and in order to get into the industry, a bunch of early adopters have a proprietary protocol. Is that sort of how it starts?
Yeah, it's not uncommon. Yeah.
And then eventually there's a bunch of groups that decide I'm going to do this standard and this standard and this standard. And, they trickle down to maybe a couple or a few. And now you support, or many companies then slowly supporting a small amount of those standards because no one wins. Is that sort of like how you summarized it?
That's right. Our expectation, if you look in the home today, arguably around the world, you can list off 20 or 30 actual standards that are in use in the home, and many of them are regional, right? But generally, you can get agreement that that's likely to collapse down to probably 2 or 3 primary standards that will get used the most. And we can argue what those are going to be, and everyone loves to, for in the home. And then similarly, even in commercial building, because that might not be the same. So it's actually quite natural for a market to start with lots of different things and then consolidate as consumers get to use it. And I see this, my poor wife has to live with this because I want to install and try things. And at some point she says, how many apps do I need to have on my phone to talk to things in our house? Because if I have one app that talks to the thermostat and another app to talk to my light bulbs, and another app to talk to different light bulbs, and then a different one for the home security system, right? People don't actually want 10 apps on their smartphone to control their house. That's a little confusing.
People I think don't really realize this, but HTML is a standard too, right?
Yep. Yeah, but HTML isn't used in battery operated devices like we're talking about here, right? So, you know, we need to make, you know, little things like battery operated light switches, right, that are going to last 7 to 10 years on a coin cell battery. And so, right, that is simply one chip and some external components to go do that. And you can put it anywhere in your house, and you can move it around. And you see in Zigbee now, people really starting to do some of these that are actually energy harvesting. So there's no battery, and you get to clunk a big switch like the good old days, and that, you know, that clunking of the big switch is enough energy to send out the messages to turn your light on and off. Right? So for that to work, right, this is really, you know, all about consolidation down to how do I make this as simple, low cost as possible and really save energy. And so when you do that, you're not thinking running JavaScripts and playing fun videos on your light switches, because you can't do that on battery operated devices.
I'm not sure I quite got that. So what you're saying is it's easier to make standards happen on HTML than it is in the IoT space?
No. What we've traditionally fought not fought, but had to explain in the low power wireless space is if I'd like to make a door lock, right? Door locks are battery operated, and people say, well, what traditionally happens is cloud companies come in and say, we know how to do this. We've got a cloud here, and it talks HTTP, you know, it talks TCP and things like that, and they say that's excellent. Let me put that on my light switch. And I can do that, and my light switch, you know, lasts for you know, a good week or so before you need to recharge it, and you know, it crashes only once in a while. Don't worry about that, right? But we're putting wireless connectivity into the simplest of devices, right? And so if this is, it's actually not very difficult, right? How often have you dropped a cell phone call, right?
Daily.
Yeah, how often do you know that there's areas where you live or where you work where it's like, I can't get good coverage there. I don't have Wi-Fi coverage there, right? Or I can't get cellular coverage there. I got to walk to the other side of the building. And that works great because we've got trained monkeys in a loop called us that will walk around and adjust or redial, right? So let's take your thermostat. You know, how often do you think your thermostat should work? Because quite often people think it should work all the time, right? And when you walk up to a light switch and you flick the light switch, there's actually only one thing that can happen, right? The light needs to turn on, or you go replace the bulb. You don't go, I wonder if the internet's down today, right? It's just not possible, right? And so we have to take this, you know, very simple devices, embed wireless in them, and keep the consumer expectation of generally, you know, pretty much 5 nines of reliability, right? It has to work all the time.
So what you're saying is that us trained monkeys have started to accept originally the blue screen of death on our Windows machines.
That's
and
right.
Eventually now we're kind of like, this has sort of permeated through our lives, that we kind of like, okay, with cell don't working, cell phones dropping, to anything. But when we go to a light switch or something, we expect it to turn on or off. There's no sort of like, oops, sorry, I got to reboot my light switch.
And to be fair, if IoT is actually going to be successful, right? And if your mother's going to use it, if the non-techie is going to use it, you can't be talking about rebooting your house. You can't be talking about, oh yeah, take your light switch off the wall and there's a little reset button you could hit on the back and then it probably should rejoin and work okay, right? You can't do that.
I'll never forget this. It's a long time ago, and you're really explaining a situation I had. I was out on a date, and my kid's grandmother was babysitting, and she called me and panicked. Robert, the whole house went dark because I had this fantastic idea that on this one button, if I triple click down, that would mean it turns off the whole house.
Yeah.
Well, she didn't know that, so she turned the whole house black. So that was pretty funny. So that's your point. I get it. So I guess I want to turn this around. Why do companies like Apple or Google, and I on purpose use those two, want to even have standards, right?
Yeah.
I think I know that Apple is really not into standards. They're in their own ecosystem because of reasons that I think you're going to talk about. And Google, on the other hand, is. What's the thought? Why?
I mean, they can probably answer better than I can, but right, Apple has tended to do their own thing, right? So even if they use a standard, they seem to want to tweak it a little bit. Then they came out with HomeKit, which is their own kind of connected home and device ecosystem. And to be fair, they have a big enough ecosystem they can probably drag people along. And then Google bought Nest, which was doing its own thing. Obviously, the networking stack they're using is standards-based because it's Thread, but their application layer is their own. And at some point, they've said they're going to open that up and let other people use it. But I think many of these big companies, we see a real variation, right? They think they want to control everything and provide the best user experience, and quite often they can, because they totally curate everything they do. Now, the problem in the home is, and we see this, and other people have a much more open approach. Like Amazon has now released the Echo Plus, which has Zigbee in it, and Zigbee devices can connect to it, and so it's a much more open ecosystem. And we'll see how successful they are with that, because it's really now just launching. But the problem in the home is very acute in that there is no single manufacturer that makes things for your home. So Apple, if you decide you want to be part of the Apple ecosystem and you want to buy, a Mac laptop and you want to use, an iPhone, that's great, right? Who else uses your laptop and your phone? That's really a personal choice you're making. Who uses your door lock? Because a lot of people use your door lock, right? And the chance that your door lock is made by the same people that make the light bulbs in your house or the appliances, or that even the light bulbs in your house are all from the same manufacturer, there's no chance of that, right? They have to come from different manufacturers. You go to the store to get replacement light bulbs. You don't go, oh, I can only use this brand or that brand. You buy whatever you think is appropriate for you this time. And if it's a different brand of bulb, you still expect it to work the same. So as we move into connected devices in the home, right, it is a very challenging ecosystem, right?
But if I start buying Philips Hue light bulbs, I can't mix that with an Osram light bulb or something like this, can I?
If they're all Zigbee light bulbs, you absolutely can mix them, right? They can all join the same network. Now, if I buy a Philips color controlled light bulb and I buy an Osram, dimmable white, they're gonna obviously behave differently. But if I send them both an off command, they're gonna turn off. Right? If I send them on, they're going to turn on. The color one gives me more capabilities and things like that. But I can put them on the same network. I can get, the same joining. They can all be controlled from a singular app and things like that if I so choose. And so that's where standards, particularly in the home, right, really matter, right? The simple case is, if you want, when you unlock your door and it's dark out, therefore, you'd like your front hall light to come on automatically, right? Then your door lock and your light bulb probably need to talk the same language. They don't have to. I can go to the cloud and I can integrate everything in the cloud, but if the internet is down and you still want that behavior to work, then that doesn't actually work if you go to the cloud for that basic interpretation.
If you're just joining us, I'm Robert Schmid, the Chief IoT Technologist for Deloitte, and you're watching Coffee with Mr. IoT. Today, I am talking to Skip Ashton from Silicon Labs, and we're just riffing on standards and home equipment and light bulbs as of lately. I got a question for you. You know, you are on, as I said, as I know, you work on the Wi-Fi, you work on Bluetooth, you talked about Zigbee, you talked about Schmid. Um, what about the Open Fog Consortium? And I don't know, for people who don't know, fog is all about edge computing. What's your thought on that? Are you going to get onto that too? Are you on it already? I'm just
Yeah, I
curious.
mean, so we're not part of Open Fog. We do spend a lot of time working on either gateways or access points that live on the edge of these networks because, you know, when we first started this, people wanted kind of standalone networks, and now, you know, a device isn't connected if I can't connect it to the cloud or connect it to my smartphone. And so there's a lot of functionality that goes into that. But if you look at how the internet has developed, and the reason, you know, one of the reasons people give of the success of it is if you go to the store today and you buy a Wi-Fi device, whatever it is, I don't care, your favorite Wi-Fi coffee pot, so you can have, you know, Mr. IoT coffee in the morning, right?
It's a
Then
Christmas cup.
what
Look,
you're
I'm almost in style. I'm a little early, but it's
you're a
not
little early.
Thanksgiving.
That's right. So your expectation when you bring that home is that Wi-Fi device is going to connect to your Wi-Fi access point. And Wi-Fi through the years has gone through A, B, G, N, and, you know, MIMO, and they've done lots of different changes. But your expectation remains that when you bring a Wi-Fi device home, it connects, right? And if you look at many of these, you know, gateways that do a lot of application level functionality, if that gateway has never seen your Wi-Fi connected coffee pot, then when it connects, it has no ability to control it. And so it needs a software update. And for most of us, we don't go around wondering when we should next update the software in our Wi-Fi access point or in our edge boxes in our house, because we just never do that. And so, you know, there's a challenge in the home in having this kind of distributed computing and distributed knowledge if it's not a very curated ecosystem. So your set-top box is a perfect place to put that because, not surprisingly, that's a very managed box. Whereas your Wi-Fi access point probably is not a managed box, but it is in a commercial or industrial setting where they want to distribute that level of intelligence. So it has a place, but it really, you know, it depends on what market and what ecosystem you're trying to go after with it.
Are you questioning fog in general as something that's going to take off?
I mean, we obviously see people building smarter and smarter devices on the edge, the device itself, right? They'd like more smarts, more intelligence in the device, which is a little bit different than putting the intelligence in a gateway or edge box for us, right? We believe people do want their devices to get smarter and smarter. There's we think a bit of a challenge in making the gateway box smarter and smarter.
So I'm curious, you relate this back to the software update on the device, right? And I've really had sort of like this sort of awakening when I first used the Chromebook. And the awakening around the Chromebook was that, first of all, it boots up in less than 60 seconds. It's really fast. It's like, I don't know, 6-7 seconds. Second, that thing just updates itself. So I gave my mom a Chromebook, and I have never gotten that call from my mom that the thing doesn't work. She's called me about things she doesn't know how to do, but the thing boots up, the thing reboots itself, it's updated. I don't have to worry about it, right? And
Yes.
so this is sort of like the shift about this. Whose responsibility is it to update itself, right? So is this an ownership issue that I own the edge device, or that it updates, or is it actually an issue of how we handle it? What do you call it? The trained monkey in us?
Yeah, there's a real, there is an expectation problem because, you know, for many of our devices, we're willing to live with software updates happening all the time on them, right? Your cell phone, you get updates to apps and things like that all the time in the background, and you don't notice. We've really become accustomed to it. The problem, of course, is who can do a software update to your light bulb? And when they do that, should your light switch still work at the same time? And you probably think it should. And so, you know, it's fine if they're adding new features, new functionality, they're fixing, you know, the latest security article that they are now nervous about, things like that. But, you know, most companies are very concerned, right? If I sell 1 million light bulbs and I push a software update out that works in most of them, and it bricks some of them, I probably have some very grumpy customers. And there's plenty of use cases out there of, unfortunately, people bricking devices. We had one recently where we saw, people brick some door locks, which is a pretty unfortunate device to brick. People brick gateways with an update that they couldn't update and needed to mail the gateway back in and things like that. So, many companies are very nervous about updating these small devices because typically, when you look at, I've got a single device here, right? I'm not running an OS. I don't have Linux down here, things like that, and I'm just updating an app like on your phone or something like that. You're updating the entire device. You're putting a whole new stack in there and a whole new application layer and saying this is the new one and it works okay. And absolutely, nowadays, everyone believes they have to do that, right? It's very important, but they're also very concerned that they do it well and that they don't, strand devices or things like that. And so that this again gets back to the managed ecosystems versus kind of open ecosystems, right? So if you're buying into, a managed ecosystem, if Comcast is managing the devices in your house, they're going to take care of that for you. And some people are going to say, that's worth it to me. I don't want to have to worry about this. I'm willing to pay a monthly fee, whatever the service is to get this, and I'll do that. And other people say, no, I'm going to buy these. I'm going to plug them in. I've got all these different ones in my home. It's great. And who owns those? Who controls those? Who's allowed to do software updates to them? What happens if things go wrong is a little more exciting then.
See, I have this vision that IDC says by 2019, I believe, or 2020, that 40% of all processing happens on the edge. So I'm super interested to hear how you talk about these updates and how nervous people are. It's absolutely true. Yet I think it has to become sort of like the thing we all need to do. It's gonna have to become, as us in the software and in the hardware, we just got to do it, and it's our job to not brick it. But here's the other thing to this. I think that if we want to have 40% of all processing happen on the edge or near us, ambient us, whatever we want to call it, I don't know. I have this vision that unfortunately 110 isn't gonna go away, and every single outlet will be a computer. And then, if every outlet is a computer, what does that mean? What are we going to do with that? And that's how I'm thinking about this. I don't know. Am I crazy?
Well, to be fair,
you don't know. Is that a crazy idea? I should ask.
Yeah. You're definitely crazy. But that idea, so I think in some ways we're saying the same thing, is we expect the devices themselves to get smarter, which to me is a little bit different than saying, and maybe it's a nomenclature and a naming thing, the open fog of how much of that processing is in a gateway box at the edge where it's collecting all the sensor data, or how much of that processing is in the sensor itself, where the sensor, does a deeper analysis. I mean, we see this today. There's all sorts of, voice analysis going on. There's all sorts of stuff that's getting pushed out into the actual devices themselves. So the devices are getting smarter and smarter. But if I'm going to put a little Linux box in every outlet in your house, right? We had this problem when people looked at smart energy and said, well, I really want to be able to reach into your home and control power consumption so we don't have brownouts, all that sort of stuff. But if the goal is saving power, if I'm going to put a little computer and everything in your house, the actual net power load I'm going to do so that I can save at that peak time is quite exciting, because those consume a lot of power, right? And
I thought you guys made that go away. I thought you make everything so small and so efficient that the power consumption is negligible compared to the savings you're going to get me.
It depends on how much compute you want to do, right? So, right, this is the argument over keeping it simple, keeping the standard slim and things like that, so that I can get away with, even in a device that's powered, how much vampire load do I want, right? There's energy regulations, right? California's pushing, right? What's the standby power of your light bulb, right? What is the standby power of the devices in your home? We talk about the Viper load with these power supplies plugged in and things like that, but not about that wireless chip in that light bulb is drawing load right now so that it has a radio on, so that if you send it a message to turn on, it receives it. How else is it going to get the message, right? And as a consumer, you're not willing to wait. I mean, I can have the bulb duty cycle, so it just takes a few seconds for it to come on. But mysteriously, people get grumpy if their light bulbs take a few seconds to come on.
Yeah, exactly. Skip, I think we are coming towards the end of it. I want to come back to what we started with. You talked about the passion your kids are liking, or I'm sometimes not liking. What are you really passionate about in this? Where do you want to go? What does your passion drive you in all this?
I mean, I am very passionate about doing the standards and doing them right, because I think that is the success of the industry is coupled to that. And for that to work, we all have to work together on it. And I've been fortunate generally that we've been in organizations that have pushed hard to do that. That the collective good, while we need to compete with each other in the marketplace, within the standard, we actually need to cooperate.
Skip, as always, it's a pleasure to talking with you. Thank you for what you do. Thank you for taking your time and putting it into something that seems odd for some people who compete with each other all the time. So it shows how it actually benefits not just your company, but all of us. So thank you for that. Thanks for being on the show. And
good fun. Thank you very much.
Yeah, with that, I just want to say, please join us next Friday, 9 a.m. again. Oh, next Friday is Thanksgiving. We will not be on next Friday, but Friday in 2 weeks for another coffee with Mr. IoT. And by the way, if you missed any part of today's conversations or last week, please watch our episodes again on my YouTube channel. And with that, Skip, thank you so much. Have a good one. Have a great weekend.
Thanks. Bye-bye.
Bye.